talk about convex mirror and see what are the different cases where objects can be placed in front of convex mirror, and how for theoretical questions where data has not been given and still the question asks what is the nature of image, what is the size of image, where the image has been formed, etc, etc, erect, virtual, real, virtual, erect, inverted, different things. Okay, now similarly as we have done in concave mirror, see this is convex mirror. I have explained to you, if you remember, using hand. If this is the front part of the mirror, this is the back part of the mirror, then this is a plane mirror which you see, this is a plane mirror, and if you bend towards yourself it becomes concave mirror, and if you bend on the other side it becomes convex mirror. So similarly if you see here, this is a convex mirror, correct? Now since if you remember, it can be a part of a circle, since it is in form of an arc. There has to be if you draw a circle, a rough circle here, there has to be a center which we term it as center of curvature. Center of curvature, because it is not a full circle but still in the form of a curvature or an arc, so there has to be a center, that is called center of curvature. And similarly, in case of concave mirror, there has to be a focus point over here between pole and center of curvature, and pole is a point where this horizontal line called as axis intersects the mirror, correct? Now if you see it carefully, it is different from concave mirror. Focus point and center of curvature in case of concave mirror was falling on left hand side. Why? Because mirror was facing this side, correct, the front part, whereas this convex mirror is actually curved towards the opposite side, and because of which center of curvature, focus point, both lies behind the mirror, whereas in case of concave mirror they were lying in front of the mirror. So that is also a point which you can distinguish between concave mirror and convex mirror. Center of curvature and focus point in convex mirror lies behind the mirror, but center of curvature and focus point in case of concave mirror lies in front of the mirror. Now as we have done in concave mirror, we have pole, and we will make this pole as origin by drawing a y-axis passing through this pole. This is positive y-axis, this is negative y-axis. So this becomes positive x-axis and this becomes negative x-axis, correct? Now we had 6 different cases in case of concave mirror where objects can be placed, because in front of the concave mirror there were 2 different points C and F, but here we see there is no such point in front of convex mirror. So it means there are only 2 possibilities. Either the object is placed very far from the mirror, convex mirror, or the object is placed at a considerable distance in front of the convex mirror. There are only 2 cases. There are no points lying on this negative x-axis or the axis in front of convex mirror. That is why we are considering only 2 cases. The first case is the object is placed at a very far distance, or the object is placed at a considerable distance or near to the convex mirror, in front of the convex mirror, correct? So it means the first case which we should analyze is, for theoretical question, is the object is placed at a very far distance, that is at infinity. Before that, if you see this mirror, this center point, center of curvature, is lying on positive x-axis this time. Why? Because convex mirror is curved towards behind the mirror, and this center of curvature is falling on positive x-axis, whereas this focus point is also falling on positive x-axis. So for the sake of convenience, as we have done in cases of concave mirror for theoretical questions, I am repeating it again and again for theoretical questions, so that you do not build up a concept in mind that every time in all question you have to take r is equal to 10 or f is equal to 5. These are only for theoretical question where no data has been given. So this time, if you see, center of curvature is lying on positive x-axis, so this distance should be positive. So Unlike in concave mirror, we have taken R as positive 10 centimeter this time, and automatically, since for small apertures in case of spherical mirrors, focal length is half of radius, automatically this focal length, that is the distance of point F, focus point from pole, will become plus 5 centimeter. Correct? Now the first case is the object is placed at infinity, at a very far distance. The object is placed at infinity. Okay? Now, as we have solved different cases in concave mirror, in the same way we will get 4 results in convex mirror also using the same mirror formula, that is 1 by V plus 1 by U is equal to 1 by F, and magnification formula, that is height of image, that is H2 upon height of object, that is H1, is equal to minus V by U, where V and U are horizontal distances and H2 and H1 are vertical distances, that is height of image and object. So using the first formula, that is mirror formula, where I will write the values of U and F. U is equal to minus infinity. Why minus infinity? Because the object is placed in front of the mirror, and since pole is the origin and this line is negative x-axis, and since the object is placed on this negative x-axis, this infinity should be minus infinity. U is equal to minus infinity and F is equal to plus 5 centimeter. Correct? Because focus point is lying on positive x-axis this time due to the curvature of convex mirror on the other side. So this is our first case. Now we will use the mirror formula and let us see what are the 2 results which we can get. 1 by V plus 1 by U is equal to 1 by F. Right? Now if I substitute the values of U and F in this equation becomes 1 by V plus 1 by minus infinity is equal to 1 by 5. Or betterly we can write it as 1 by V minus 1 by infinity is equal to 1 by 5. Now again, any number upon 0 is infinity, implies any number upon infinity should be 0. So here 1 by infinity should be 0. So left hand side will become 1 by V minus 0, and 0 subtracted from any number results in the number itself. So it should result into 1 by V itself. 1 by V minus 0 is equal to 1 by 5 is actually 1 by V is equal to 1 by 5. Correct? Which means V is equal to 5 centimeters. So we have got the first result using mirror formula, that is V is equal to 5 centimeter, and we are going to evaluate, we are going to draw the 2 results from mirror formula, that is position of image and whether the image is real or virtual. So what we can write here is, the first result we can write here is image formed at focus point. Now why focus point? Because if we try to locate this point positive 5 on x-axis, because V and U are horizontal distances and we have to locate V and U on a positive or negative x-axis. Since the value of V is coming out to be plus 5 centimeter, and if we try to locate plus 5 on positive x-axis, it comes out to be this focus point itself. Why? Because we have considered C as 10, so automatically F becomes plus 5, and since the result is coming out to be plus 5, the image is being formed at focus point itself. If you see this yellow cross, this is the place where image is being formed. Correct? So very first result is image being formed at focus point, that you can see in the tabular form also of the different cases of convex mirror where the objects are being placed. Now the second result is image, if you see, this is the front part of the convex mirror. This is the front part of the mirror. So left hand side is the front part of the convex mirror and right hand side is the back part of the mirror, or it is forming behind the convex mirror. The image is being formed behind the convex mirror. So it means the image is virtual. Whenever, like we have seen so many cases as of now, whenever the image is formed in front of the mirror, the image is real, and when the image is being formed behind the mirror, image should be virtual. And that is what happening in this case also. Image is being formed behind the mirror, that is why image is virtual. Now if we use magnification formula, let us see what results we can draw. H2 upon H1 is equal to minus V by U. What is the value of V we are getting over here by calculation? That is plus 5 centimeter, correct? And what is the value of V have considered for theoretical questions when the object is placed at a very far distance in front of the convex mirror is minus infinity. Why minus? Because this distance is lying on negative x-axis when we have considered pole as origin. So this becomes H2 upon H1 is equal to minus of 5 divided by minus of infinity. Correct? This minus gets cancelled, and once again any number upon infinity is 0, because any number upon 0 should be infinity. So any number upon infinity should be 0. So this becomes H2 upon H1 is equal to 0. Or if we take H1 on the right hand side, this H2 becomes H2 is equal to 0 times H2. Correct? Now any number multiplied with 0 results in 0 itself. So whatever the height of the object may be, since it is being multiplied with 0, the height of image should be 0. Now height of image should be 0, or in other words, if it is coming out to be 0, means it does not have any length toward positive y-axis or negative y-axis. It is just lying on x-axis. Or in other words, the image is just a point-sized object or highly diminished. So if we use this calculation to find or to draw the other two results, the other two results we can write is image is highly diminished or point size image. Correct? Now there is no sense if I say how can a point be erect or inverted, but since we have to write something and this value is coming out to be, it does not have any negative sign into it, since the negative sign gets cancelled, we can write the image is erect. I repeat, since it is a point, there is no sense of saying erect or inverted, but still for the sake of writing the answer we can write it as erect, because it does not have any negative sign into it during calculation. The negative signs which we had here gets cancelled. Okay, so finally we have 4 results for the very first case of position of object in front of convex mirror. Now the first case is the object is placed at a very far distance in front of convex mirror, and that very far distance can be termed as infinity, and since pole is the origin and this line of x-axis is negative, so this distance should be minus infinity. For the sake of convenience, like I have repeated n number of times as of now, for theoretical questions and for the sake of convenience for calculation, we are considering very simple numbers 10 and 5. 10 is radius or the distance of C from pole, F is focal length or distance of focus point from pole. These values are positive just because these points are lying on positive x-axis this time, and U is minus infinity. We substitute these values in mirror formula and we finally get V is equal to 5 centimeter, which is positive, and since the value is positive, so it means the image is forming behind the mirror, and since focus point is also 5 centimeter or the focal length is also 5 centimeter, and the distance of image from pole is turning out to be also 5 centimeter, it means the image is forming at focus point itself. Correct? And also since the image is being formed behind the mirror, the image should be virtual. Since it is not forming in front of the mirror, like we have seen few cases in concave mirror, the image was forming in front of the mirror, so image was real. But in this case, the image is being formed behind the mirror, so it should be virtual. Also, using magnification formula, we have got h2 is equal to 0 times h1. Any number multiplied with 0 results in 0. So whatever the height may be of object, the height of image turns out to be 0, or in short, it is a point size image, or in other words, highly diminished. That is what I have written in the first result using magnification formula. The image is highly diminished, that is point size image. And also it can be set erect because it is coming out to be positive during calculation, although it does not make any sense since a point cannot be erect or inverted, it is just a point. Okay, so this was the first case of position of object in front of convex mirror. Let us see the second case. Also, don't forget, this is just a point, so you can mark a point over here, just a point. Okay, now let us see the second case where the object can be placed in front of the convex mirror. There are only two possible cases because you cannot see any point marked on negative x-axis, so there can be only two cases, either very far or near to pole in front of the convex mirror. Okay? So I hope you understand now why there were 6 cases in case of concave mirrors and why there are only 2 cases in case of convex mirror. In case of concave mirror, both focus point and center of curvature were lying in front of the mirror. Why? Because it was curved this way, correct? And in case of convex mirror, since both center of curvature and focus point are lying behind the mirror, there are no points marked in front of the mirror, so there are only 2 possible cases. Either the object is very far or at a considerable distance or near to the pole in front of the convex mirror. So let us see the second case now.
No more spending your energy and money on coaching classes or missing classes for rain, for rally and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now the second case is the object is placed anywhere between pole and the farthest distance. We can take any number when theoretical questions have been given and no data has been provided, but still the question asks what is the nature of image, what is size of image, where the object is placed, where is the image formed, etc., etc. We can take any value, there is no constraint. Okay, so this farthest case is over now, and suppose if I draw object over here, okay, in front of the convex mirror, and if I say this distance of object from the mirror is any number, say 20, no problem, I can take 20 also. Since this position of object is lying on negative x-axis, so this point should be minus 20. It's okay, in magnitude it is 20, but if I mark it with sign, it should be negative. Why? Because it is lying on negative x-axis. I repeat, you can take any value. For the sake of convenience, I am taking just 20. So I will write here u as minus 20. F remains same, that is 5. Focus point, focal length is 5 cm, since the center of curvature is at 10 cm from the pole. So focal length becomes 5 cm, that will remain same. And since the second case, which is the last case, object is supposed to be placed anywhere between pole and infinity, I have taken minus 20. I repeat, you can take any value, it's up to your wish. The results will be same. I mean, the values of the results will differ, but the answers for theoretical questions will be same. Okay. Now let us see, using mirror formula, what results we get for this particular case. So I write this mirror formula once again over here. 1 by v plus 1 by u is equal to 1 by f. I will substitute the values of u and f in this equation, and this equation will become as 1 by v plus 1 by minus 20 is equal to 1 by 5, or betterly we can write it as 1 by v minus 1 by 20 is equal to 1 by 5. If I take this negative value on the right hand side, it will become positive, and there is already a positive value 1 by 5 on the right hand side. So it becomes 1 by v is equal to 1 by 20 plus 1 by 5. Correct? Now you don't have to subtract anymore on the right hand side this time. Everything is going to be added. So the denominator of the second fraction gets multiplied with the first numerator of the first fraction. The denominator of the first fraction gets multiplied with the numerator of the second fraction. So this becomes 5 plus 20 upon 5 into 20, and like every time I am not writing the result of multiplication in the denominator because something might get cancelled from numerator after I add the two numbers in the numerator. So this 1 by v becomes 5 plus 20 is 25 upon 5 into 20. Correct? Now 5 into 5 is 25. So we will invert the equation. V will become, this implies v becomes 20 by 5. Correct? Now 5 into 4 is 20, so it becomes 4. So in short, we have v is equal to 4 centimeters. Correct? So finally, by taking u as minus 20, why minus? Because the object is placed on negative x-axis, that is in front of the convex mirror, in front of the pole. So I have already said you that you can take any number, the results will be same. The value can vary, but the statement of the results will be same. So I have taken 20, u as minus 20. Why minus? Because on negative x-axis, f remains same plus 5, and I have substituted in the mirror formula, and finally I have got v is equal to plus 4 centimeters. Now this plus 4 means, if I want to draw two results from this mirror formula, this plus 4 means the object when placed at any point in front of the convex mirror, the image is formed between pole and focus point. Why? Because this focus point is plus 5, as I have considered C as plus 10, this focus will be plus 5, half of the value of radius. So 4 is just ahead of focus point. So I can say the image is being formed between pole and focus. Okay. So the first result is image formed between pole and focus point. Correct? Now again, if you see, the image is formed behind the mirror. This shaded portion tells us that this part, the right hand side part of the mirror, is back part of the mirror, and the left hand side part of the mirror is front side of the mirror. So again, the image is being formed behind the mirror. So I can say the image is virtual or virtual image. Correct? So two results I have from mirror formula is that is, the first result is location of image, that is, image is formed between P and F, and the image is virtual because it has been formed behind the mirror. If I use magnification formula, H2 by H1 is equal to minus V by U, and I substitute the values of V and U in this equation, then it becomes minus of 4 divided by minus of 20, because the value of U is minus 20 and V comes out to be plus 4 centimeters, so it becomes minus 4 upon minus 20. Minus sign gets cancelled, 4 into 5 is 20, so H2 becomes 1 by 5 into H1, or I can say H2 is equal to 0.2 times H1. Correct? So I have found the result. Height of image is 0.2 times height of object, or height of object is being multiplied with a number which is less than 1. Now if you remember that example which I have stated, if the multiplying factor is greater than 1, then the output is greater than the input. If the multiplying factor is equal to 1, then the output is equal to input, and if the multiplying factor is less than 1, then the output is less than input. If you remember that 100 rupees example, if I have 100 rupees and if you have 0.9 rupees, the multiplying factor is less than 1, then the output, the result, the money you will have will be 0.9 into 100, that is 90. So the output is less than input. Correct? So it means whatever the height of object may be, the height of image will be less than it. Why? Because the multiplying factor is turning out to be less than 1. So the first result I can write is image is diminished. And the second result, since this value is turning out to be positive, so it should be erect and not inverted. If you remember, we have seen so many cases as of now. If the value of height of image turns out to be positive, the height should be, or the image should be erect. If it turns out to be negative, then it should be inverted. But since here it turns out to be positive, so it should be erect. Erect image. Correct? Now I have the location of image, that is between P and F. I have the result, that is image is diminished. Whatever the height of object is, the height of image will be less than the height of object. Correct? So if I have used this white arrow as the height of the object, then the height of the image should be less than height of the object. If you see this yellow arrow above this cross sign tells us that this is the place where image is being formed, and this arrow tells us the height of image. So this yellow arrow is smaller than white arrow, which is the height of the object. So it means height of image is less than height of the object, and that is what the result we have here. Correct? So this is the way we have found that there are two possible cases in case of convex mirror where the objects can be placed in front of it. Why? Because we do not have any points marked on this negative x-axis, the number line, and there are only two ways where objects can be placed, either very far from the convex mirror or the pole, or very near to the pole, and we can get the two results also. Now if you compare the 6 cases of concave mirrors and 2 possible cases of convex mirror, in case of convex mirror we have every time got the result as the image is being formed behind the mirror. The image is always virtual, right? But it was not in case of concave mirrors. In majority cases we got the image as real, and in very few, 1 or 2 couple of cases we have got image as virtual. So it means if you use convex mirror, wherever the object is placed, doesn't matter, the image will be virtual. That is why you will appreciate if I tell you, in vehicles, the mirror which we use, the side mirrors which the drivers use while driving a 4-wheeler or a number of wheelers, they have convex mirror placed as side mirror, and the image is always virtual. How do we come to know that? By seeing these cases, 2 possible cases of convex mirror. Now since we are done with the tabular forms of different possible cases of objects which can be placed in front of concave mirror, we have seen that the different cases, the tabular form, the different cases where the objects can be placed in front of convex mirror. Now we will try to figure out what are the different properties and what are the different aspects we can use to differentiate concave mirror and convex mirror together.